My name is Brendan Shaklovitz. I'm a site reliability engineer at Atlassian. I've been with the company about 6 years, and I've been with the security team for about 2.5 years. And I'm here today to talk to you about what I learned from deploying Osquery at scale to 30,000 hosts. So, late 2016 and early 2017 is really the origin story for Osquery at Atlassian. And this is probably where many people attending are at today. To us, Osquery looked like this great tool to gain additional endpoint security visibility. With Osquery, we could find out what processes were started and when, what programs are installed and running, if there's any processes that are weird, suspicious, running from temp or out of memory. We could see what operating system and kernel versions are running everywhere. And basically, we wanted to run Osquery everywhere to significantly increase the amount of visibility that we had overall across our fleet. We had these really lofty goals for what Osquery could do for us at this point, but we didn't really know how to use it to its full extent. The problems that we would face along the way, how we would get it installed everywhere, and what sort of alerts we would need to take full advantage of the data. So in 2016, 2017, we took this one small step to improve our security posture, which was getting Osquery installed from these statically compiled configurations built into like Debian and RPM packages and deploying that everywhere. And this had lots of, probably obvious problems to many of you, but it was great for kind of a proof of concept and getting started phase. And it let us get Osquery out quickly to kind of lots of places in our environment. Not 100%, but to a kind of large enough portion to be useful and to get some useful data. So looking back, this was before I started, but I could find some documentation on this, which I found was pretty useful. And I'd like to share it with you just as a I think it's important to understand why you want to use Osquery and how it will fit in with your security story and with your company's values. And so for us, the guiding principles were we wanted to maintain employee autonomy over their computing environment. So Osquery is a good fit for this because it doesn't impose a lot of additional controls. It's mostly collecting information. It's largely read-only. We wanted to have an unobtrusive approach to Osquery data collection. And we wanted to be transparent with the data that we collected. And the way that we were transparent with the data that we collect is internally we have a Git repo where we have the configuration and we share that with all of our employees so everyone can see exactly what queries are going to be run. And if they're interested, they can take those queries and run them with Osquery AI to see kind of what sort of data is going to be sent to our centralized log store. And these map very interestingly, I think, to our company values. So maintain employee autonomy over their computing environment is like be the change you seek. And it's saying we don't want to interfere with employees and how they work and being able to do the best work that they can do. The second one corresponds kind of to don't fuck the customer. Sorry for language, but that is our value. And I guess we don't want to collect unnecessary information that would not be needed. So like if there's any sort of private information, we try to avoid collecting that. Sometimes we don't succeed, but we try our best. And the last one, be transparent, corresponds to open company, don't bullshit. So this is what I was talking about as far as like sharing the repository and letting people see what data is collected. Kind of so that they can run those and figure those out. So this is where we started. We had this static config. And in early 2017, we had a big security incident with HipChat that made us realize just how far away we were from where we wanted to be with Osquery. An attacker used a then unknown vulnerability in GhostScript to attack HipChat. And unfortunately, this was not detected by Osquery due to how immature our processes and deployment were at that time. But even so, even without Osquery not being to where we are today, we were very lucky because we were at least collecting the information about process executions at that time. So once we knew that something was amiss, we could kind of go back in time through our logs in Splunk, through our Osquery data, and we could kind of see what happened when. And we could look through logs for multiple different services to kind of track lateral movement of the attacker if there was any, and see the information across machines. So even though we kind of had these static configurations, we couldn't really, there were a lot of limitations. This was incredibly useful for our investigations. And so this is just sort of a story to say, like, hey, if you have nothing else, even if you have just a short, like a very small deployment, it can be very useful. So the first lesson that we learned from this incident was to set up some automated alerts. So here's some sort of examples, and I'll go through a couple of them and give kind of reasons why. But these are sort of some things that we realized that we should have been looking for, or just like that most people probably want to look at in general. This may be different from your environment. There's probably exceptions for this, valid use cases for each of these, but in a lot of cases, doing a lot of these things is sort of suspicious and is sort of a signal for us to investigate further. So I'll pick apart a couple of them. So long running processes from temp. So normally you're going to be running executables that are installed in a specific location. They're not going to be, just written out randomly. And so something running in the temp directory may be a sign that, like, okay, malware has written something because this is world writable, and it's running an executable out of the temp folder. Is kind of an example. The second line where I see VNC servers, I guess the reason why that's interesting is not necessarily that VNC itself is suspicious, but that if you know that you don't run VNC on your systems and you see it running, then that could be a sign that somebody's trying to do some remote access of your systems. And similarly for kind of all of these, which I won't go through all of them in a lot of detail, but in a lot of the cases, these can be signs of sort of malicious activity, and at least something that you want to be aware of. So this was kind of the first lesson that we didn't really have, is we needed to get alerts set up to automate detecting a lot of these things, so we're not just finding out about it in the investigation portion of our security program. So the second lesson that we learned from this experience was that we definitely should have been using an Osquery fleet manager. For the initial proof of concept phase of Osquery, where we were at the time, we were using static configs bundled with Debian and RPM packages, and there wasn't a quick way to update the set of queries running on the hosts or kind of do ad hoc one-time queries, which really limited the usefulness of Osquery in the incident investigation. And so, like, you may find some signal that is specific to an attack that has information that you're not collecting with the queries that you normally schedule. And if you're not collecting that information from Osquery already, if you have static configs, it's going to be really tough to kind of get that out everywhere. Or even if it's not difficult, it may take some time and increase your response to the incident. So after the 2017 incident, we decided to start using Fleet, which is an open source Osquery management system, and it lets us update our scheduled queries on the fly, as well as run ad hoc queries. And so this deployment of Fleet took place around the end of 2017 and the beginning of 2018. So I guess that takes us to 2018 and 2019. So up to this point, I've been kind of recreating the history because this is about the time when I joined the security SRE team as the second SRE on the team. So up to this point, all of the Osquery management had kind of been done as this part-time heroics from our security analysts and our one engineer on the SRE team. Many of the processes that we had in place were not automated, and there was very minimal documentation. So throughout this year, we focused on documenting and automating our processes for installing and managing Osquery. And this kind of was kind of Confluence documentation, and it was also making Ansible playbooks for our server deployments, building scripts to deploy Osquery to macOS via Jamf, some packaging for Windows laptops via Workspace ONE, and Windows servers via group policies. So as we were planning to increase the number of hosts that were enrolled in Fleet, which was rolled out 2017, 2018, we needed to make sure that Fleet could handle the load. And it's not where it is today. There's been a lot of improvements to Fleet since then, and so we were a little bit concerned about this. So we started by setting up a test environment with a bunch of Docker containers running Osquery to kind of simulate the load of a large number of hosts. And we started with about 10,000 hosts for our simulation, 10,000 Docker containers representing 10,000 hosts. And we increased the tests up to 30,000 so that we could understand kind of what parts of the infrastructure for Fleet would be particularly problematic. And this was kind of based on our current number of hosts enrolled in Fleet and how many total hosts we had across all of our servers and workstations at the time, and then adding on some growth so that was where the 30,000 number came from. So we had some kind of headroom to grow. So we wanted to know what problems we're going to run into as we got larger. So we did end up having to do some adjustments for instance and database sizing, but we were able to handle about 30,000 hosts pretty easily, except for ad hoc queries. And at the time, this was a lot more hosts than we actually had, but we expected quite a bit of growth, which has played out to this day. So after kind of doing this load testing, where do we prioritize our deployment? So for us, we have primarily macOS workstations. So for workstations, we decided to focus on macOS, but we do have Windows and Linux workstations. This just came later on. And for servers, it's a little bit of a different story where it's primarily Linux and we have some Windows workstations. So our starting point was we wanted to focus on all of our Linux servers. And this really is based on your environment and your threat model. Maybe you have all Windows hosts and you want to focus only on Windows, or maybe you have a large number of macOS servers, something like that. This is really dependent on what your employees use and what you use for your systems. But the way that we did this was to get the largest amount of coverage and focus on production systems and securing customer data. Next, we kind of looked into process auditing. So earlier I mentioned during the previous incident that we were capturing which processes were running. And the way that we were initially doing this was from the running processes table in Osquery. And it pretty much just captures a snapshot of exactly which processes were running whenever the query executes. And this is kind of, I would say, okay at best, because you're really likely to miss a lot of information. What happens if something critical happens in between the queries and not in a long-running process? So, you might have a query interval of running processes every 10 minutes, and that's only going to catch something if it's a long-running process. You could shrink the interval to however much you want, but even if you set it to every 10 seconds, a process that only runs for 1 second will be missed here. And so you always have the chance of missing things with the running processes table. So a better way to do this is to use process auditing, which captures all the processes running on a machine. We had set this up for macOS and had been using it for quite a while without a lot of problems that we knew about. And we decided to turn this on with our Linux hosts. We did some pretty basic testing, kind of decided to turn it on for the fleet. And on the vast majority of the machines that we rolled this out to, it was perfectly fine. There are no problems. Everything was fine. But I'm telling this story so you can guess what happened. A few weeks later, we kind of narrowed down an issue with a few services that had increased resource utilization due to the process auditing change that we'd rolled out in Osquery. And at the time, this kind of resulted in us having to temporarily turn off process auditing for our fleet. So the lesson here is to test and measure everything. And we should not have rolled this out without having done much more thorough testing. And that kind of takes us to the past year, 2020. So this was where we started to focus on measuring things for success. So the first thing that we did, which we could do pretty quickly because we were already collecting the data, was to make sort of a dashboard out of the Osquery schedule data. Which the Osquery schedule table collects kind of metadata about query executions. So how much system time, how much memory was used, whether a query is deny listed or not. And so we start collecting this. This is only part of this dashboard. There's other pieces of it that also show the most chatty queries and those sorts of things, or like the worst queries that we have performance-wise. And so this was the first thing that we built just because we could build it pretty quickly and gave us kind of a good way to prioritize what sort of data we want to collect and look at. The next thing that we started to do this past year was to automate query performance testing. So we wanted to fail our CI/CD builds if the queries that we've added in a change are too expensive. So we are using Fleet, and it uses YAML formatted, specially formatted for Fleet YAML formatted queries. So it's not the same as the default JSON formatted queries if you're just using the Osquery config. So we kind of modified the profiler script that's included in the Osquery repo to support the Fleet YAML and added that to our builds so that we could sort of start detecting regressions in performance when we were modifying or adding new queries. And there's a long way to go with this. Right now, we're only running the tests on Linux, so any sort of bad configurations aren't going to be detected if they're Mac or Windows specific queries. There's a lot of things that we still want to do, but this was kind of where we started off. But that really gives us the larger question of like, how do I know if it's working? You may be sitting there going, everything is fine, but really everything's on fire. And that brings us to a major project that we've done recently, which we call Osquery Auditor. And this is kind of a simplified version of what this looks like, but essentially we run a scheduled job in AWS Lambda that connects to our asset inventory system. And for each host found in our asset inventory system, it checks for Osquery logs in Splunk and reports on whether those hosts are running Osquery, whether they're returning results for queries that they should be based on their operating system, and whether they're enrolled in Fleet, so that we can detect kind of our legacy static configuration Osquery versus our dynamic configuration currently. And then we also run reports on these so that the teams responsible for these systems will know whether their systems are running Osquery, and so that they can add it if it's not. So with that data, we're able to build these dashboards that kind of show which instances are running Osquery, are connected to Fleet, and who's responsible for this infrastructure and having it installed. And so that way we can sort of reach out to them and automate a lot of this process so that we can make sure that we have Osquery on all of our systems. And that's kind of how. So this sort of measurement has been really useful for getting us to where we are today, where we're regularly hitting over 30,000 hosts. This is from the dashboard. It's not showing all hosts, just the server hosts. If we add in our workstations, this takes us above 30,000. And we can see like, okay, there's a lot of auto scaling. Not all of these hosts are online all of the time, but at peak hours, we're maybe hitting 30 to 33,000 hosts, something like that. So what's next? Looking forward to 2021 and beyond. So our mission statement when we think about Osquery is we want to have Osquery on all systems, running useful queries, and while having limited impact. So when I say all systems, right now we just have a tool to track kind of EC2 assets, but we want to track things in Azure and GCP, possibly other compute types in AWS like EKS, and like random server closets, things like that. So that's one area that we still need to invest in. Another one is to have better configuration management. Right now, our rollout of new queries is a little bit too broad. We want to be able to target systems for rolling out in a more granular way. And I wrote launcher here, but I don't know that we actually use launcher, but something where we can get sort of auto updates of Osquery and also bundling in kind of extensions and starting to look at those. Some other kind of future looking ideas, integrating this with our zero trust system so that we could limit access to certain systems to employee machines that have Osquery installed on running. Being able to auto isolate and shut down systems in like server systems that are not running Osquery. Doing further query and schedule optimization to further reduce the impact that the queries have on running systems. Another area is adding extensions for network monitoring and DNS entries in particular. We don't know exactly what we want to do here, but we know that this is pretty interesting for us. And the other one is switching from just the process events table to the BPF process events and ESF process events tables because of performance and reliability reasons. We found the OpenBSM-based process events on Mac to be far from ideal and unreliable. And similarly, if we can get better performance from the BPF process events, we would be very happy. So we're looking to roll that out everywhere soon. And lastly, we want to continue to and advance our contributions to Osquery and Fleet. So in the past, we've worked on features, bug fixes, documentation, and issues. We definitely want to continue to do that. You can definitely find me on Slack, on the Osquery Slack. So reach out there. And we have chatted with a few other companies like over Zoom about how they use Osquery, and we would love to do more of that as well. So lessons learned. Start with why. Figure out why you want to use Osquery, how you think it fits with your company. There's going to be something different for everyone that works. Measure and test everything as much as possible. Definitely use an Osquery Fleet Manager, and make sure to set up some automated alerts on the data. Thank you, everyone.